Hi, I'm Robert, the Lightning Talk Gatecrasher, and tonight I'm going to tell you about event sourcing. Event sourcing is an often overlooked programming technique for building advanced and distributed enterprise systems. And we're going to be explaining it using Node.js as the example. But what is event sourcing exactly? Is it a methodology? Is it an architecture? They say that a picture is worth 1,000 words, so here goes. Okay, this is maybe worth 20 to 30, but it still shows you the basic premise. In the presentation before, you've luckily seen an event sequence, an event stream. So that's exactly what it is. Event store's basic assumption is that your state medium, so how you represent application state, is just a sequence of events. So in a typical application, you would normally have a set of collections, perhaps, or database tables. And that's not so with event sourcing. In event sourcing, your storage, so how you convey the state of the application, is just event streams. This represents an example event stream for an application that simulates an auction site. So first, you get an event that's called auction opened. It says that that someone has created an auction and opened it for bidding, so for placing offers. And then some events later, perhaps somebody else, has placed an offer in that auction. So as you can see, it's just a series of events, and there's no state snapshotting. There are no tables that contain the current state. Thus, essentially what we have is just a list or an array, if you will, of events. Now, those names are non-random. As you can see, they are very specific to the business domain that they represent. So auction open tells us exactly what's happened. It means that some user has intended to open an auction and invite others for bidding in it. And it's not called auction state changed or auction field set. And likewise, offer placed is not called offer list appended. So they actually capture the intent of the caller. And that's very important for our business, because then if you look in the database and all you have are event streams, you know exactly what's happened. There's no guesswork involved. So for systems such as Meteor.js, for instance, where you would rely on triggers for guessing what's been happening, so you then compare fields and just name the change somehow, in Event Store, you do the guesswork beforehand. So you emit events that actually mean something. Now, the arrow there is also for a reason. This is an append-only database. So, for instance, if some user wanted to retract their offer, for instance, because they made a mistake, they would not be able to just come out to the event store and say, hey, I just want to delete that event, I don't like it. And now you cannot do that. For a reason that I'm going to explain in a while. Anyone watched Back to the Future? Come on, I'm not judging. Okay, as we all know, messing with the past is probably a bad idea. And if we do it, then we can probably bork our whole system. And that is the case with event sourcing. Since subsequent events depend on earlier events, of course, we cannot take part in an auction that hasn't even started. We do not modify the stream. Instead, we just append the new events to at the back. So if someone wanted to retract their offer, we would need a specific event that said, for instance, offer taken back. We cannot change the past. Of course, that's all fine and dandy, but how do we make applications with it? Well, I postulate that applications are just state and behavior. And that's two things that we absolutely have to implement in any application that does something. So the first thing we're going to focus on is state keeping. We need some way to derive the current state, so a usable snapshot of the application from the event stream, because the events themselves are not very wieldy to work with in logic. So what we do is implement state keeping. Now, what you see here is an example event handler. This is a function that accepts a single event as the parameter. It's just a simple JS object, nothing very specific. and then it mutates the state of this, so of the current object, just by pushing something into its private variable. And this is actually a method copied from a class definition found in a demonstration application. One side note, this code relies on an event sourcing framework that I'm going to link to later. So as you can see, you only mutate state based on events. So the event actually had to come first. The only entry point to this function is the event. You do not call this yourself, the framework does. So we are taking a of replaced event and just applying it to the in-memory representation. Now, one thing you can notice about this handler is it's very simple. It's just 2 lines, and that's all it really needs. Also, it needs to execute the very same way every time it's called, because this is the only way that you're going to get a state representation of the current state. So this is how you derive the application state from the event stream. So you cannot rely on any environmental state, such as the current date or API calls. There's no I/O in here. It's just pure logic. Now that we've got some state to work with, we're going to implement a few methods. Actually, just one in this simple presentation. And there's another bullet point to our alphabet soup, and that's domain-driven design. Now, this is a very powerful software development methodology, but I'm going to introduce only a single item from it, and that's going to be the aggregate root. The aggregate root is a self-contained entity. It's an entity that is not non-dependent on other entities, and you can load it on its own. It does not perform lazy loading in the background. It has no references on the database level to other entities. It just stands on its own. So usually you implement it as a class or as a prototypal class in plain old ECMAScript 5. And what's important is that it's loadable on its own, and it has its own unique ID system level. Then you just code your logic in methods. So it's just plain old object-oriented programming. There's nothing very specific or fancy about this. And we're going to see such a method in a second. Methods are where you put your logic. So for instance, if you need to do any checks, to enforce any variants, or just put any conditionals in your code, you're going to do it in methods. So the very purpose of a method here is just to emit an event. And this is an example method. Is the one responsible for generating our event that we've previously seen. So this is the very same event that we have already handled in our handler. Now, this is just a class method. So it accepts some arguments, builds an object out of them, so that we have some strong typing. This looks like TypeScript perhaps a bit, but it's in plain JS still. Then we are enforcing an invariant. So auctions which have not been opened cannot be. You cannot place offers in them. That's pretty obvious. And then you just emit or stage the event. So we prepare to save it. One thing to note is that in many database abstractions, you would actually be doing the saving here. So this method could, in certain programming languages and environments, contain some I/O logic that is asynchronous by nature. This is not so in this framework, and that's because you are only staging the event for committing into the database later. So there's no I/O logic in the class. It's pure business domain logic. Now, this is the event type that we've seen a handler for, and this is the payload that's passed as the event payload into it. So that's pretty obvious. And this thing is persisted to the database as it is. So it's just appended at the end of the current event stream, and we can read it back later. Now we've got our entities that actually do something, that enforce some business logic, and that emit events to put in our database. But we still need some database to put them in. So we need a persistence layer. And in enterprise applications, we often call the database abstraction layer the repository. A repository is where you get your entities from and persist them to. So in many applications, you would, for instance, have multiple repositories, and each repository might know about different tables and different collections, per entity type. So you might have a different schema for one object type. So for instance, an auction repository that knows how to load and persist auctions. So that's the component that knows how to serialize and restore the objects to their former glory. So it reapplies the prototypes, and you do not need any of that in event sourcing, because the event always looks the same. It's got a very simple schema, and you do not need a schema-full database. In fact, I store domain events in Redis myself as JSON blobs, and it just works fine. So what we get here is just a single event repository if you want it. As you can see, this example function, this is actually a service. So it's an example of a service-oriented architecture. It uses a single repository that's, of course, taken from the closure, so it's assumed to be in the local scope from somewhere, right? But it's a single repository. It's not a repository out of many. So we just tell it which class, which entity class we need loaded, and pass it the ID. Then we get an instance in a callback that we can operate on. So we just call a method, and it emits an event for us. That's simple enough, and the framework actually does all the I/O for us. So this whole thing returns a promise. That's why the return here, and we are free from doing any I/O, any rehydration or serialization work. Now, it is common to write functions such as this one and name them services. That's because it accepts a single parent's argument that can be, for instance, a map, a JSON map that you can easily pass via get or post and, for instance, expose an HTTP API over methods. It's much more comfortable than just passing positional arguments such as this one. So that's also where you can do things such as operate on multiple entities, even given the fact that it's non-transactional. And also, if you, for instance, need to check some permissions in your application, that's where you do it. But that's where the right side of the side that you perform commands on of the application ends. The user also needs some way to retrieve the data that they have written to the database. So we've seen that the only place where we store our state on the domain side is the event stream, and well, lots of events are not very handy. So for that reason, we implement the so-called read side. The read side, or the reporting store, as CQRS calls it, is a database constructed purely for reading. So it's a read-only database. Somewhere down there, where my mouse would certainly like to go, is the client. So the client talks to the event store via some API and persists changes to it. So for instance, if they are taking place in an auction, for instance, calling the place offer method, then they're persisting the changes to the event store. And then they are reading back the current state, so the current denormalized representation from the reporting store. So this side is read-only, and this side is, for all practical purposes, write-only. Now, CQRS here stands for Command Query Responsibility Segregation, and it means that we could just put a separator here, right in the middle, where the builder is, and call those two separate systems. Now, how this reporting store is built, it could be collections, tables, or anything you want, because you are just consuming events from the event store. You are subscribing to an event stream in close to real time, and then you can do any kind of changes on the side of the reporting store that you like. In fact, you could put multiple arrows on the right side, and it will still work. You can have as many consumers as you want to. Well, of course, it communicates via some kind of protocol, such as an enterprise message bus, AMQP or RabbitMQ comes to mind, but it doesn't have to. So now you can build a representation, any representation you want. So it could be relational, even though our main database, our OLTP side isn't, our OLAP is. So we've got denormalized representations that are suitable for our queries. You can create any indices on this side, and they do not impact the writing performance in any way, because you are not waiting for any indices to be filled in. Another thing is this setup, and that's a very non-intuitive conclusion, is asynchronous. So in most applications, we expect our changes to show up in the read results as soon as we perform the operation. This is not so with CQRS, and that's a very important takeaway, because in case of such systems, they do not exhibit the read your own rights property. And that's a property we've all come to rely on. So for instance, if you place an offer in an auction and immediately query the reporting store, so MongoDB or whatever it may be, you might not get your changes, and that's very non-intuitive. So it's probably fine for most single-page applications that we are used to developing today, because we can easily simulate those changes on the client side. We do not have to poll the database every time to ask what's changed, because we know what's changed. We have just done the thing. But it's still a caveat that you need to be aware of, and it does increase the development time a bit. So this is not a architecture for small systems. In fact, I use it in a system myself that has close to 100,000 lines of code on the back end and half of that on front end. So yeah, you need some scale to put it to work. So now our system has an entity that exposes some domain logic. It can persist it and load it from the database. We can easily overlay an API on top of it, and we've got all our changes handed to us in the form of an event stream. So we've basically achieved some very nice properties, but what's more important in event sourcing is that you can use the events themselves for not just storing state, but also conveying and transporting it to different systems. And that's how you typically implement automation. So perhaps in the business process that notifies users that their auction has been opened, or someone placed an offer that bets their own. And that's the way that you do it is via events. Since you can just tail the event log and listen to changes in close real time, you can implement many different business processes based on the information received. This is an example of an event schema. As you can see, it's just a JavaScript object that tells us what's actually happened. So we got the type here. We know that someone has placed an offer in our auction. Then we know what the offer is. This is redacted for legibility, but still you expect it to be a plain object. And then you also know what sequence, so what auction ID, this is a universally unique ID, it has taken place in. So this is all you need to react to it. So for instance, you can check if the auction is your own. So for instance, if we had another property like user or owner in this payload, we would be able to write handlers that notify interested users or the owner perhaps. Now you can use this to transport it however you like. So 0MQ, AMQP, go to shop. And also, many systems today expose an API, perhaps a public API, that lets you interact with it. So you register for a key, and then you can do whatever you want via, I don't know, RPC or HTTP REST. But a common pitfall of those systems is that while you can write to them quite easily, reading is not so obvious, because you still need to do some polling, to do some querying into the systems to find what's in there, and you do not get any real-time notifications between systems. While being a user, a browser user for systems is nowadays often supplanted with, for instance, Meteor.js or real-time notifications for the immediate user, you do not often get that same luxury between systems. And since our systems are built on automation by listening to messages, there is no reason not to export the same event stream to the outside. So you might, for instance, create an RSS or ATOM feed and just tell your API partner who's integrating with your system to subscribe to it and reflect the changes in someone else's system. For instance, I've got a system running in production that issues invoices, and another system is just consuming the event stream, and it reflects the invoices on the other side. So it prints them to PDF and so on. And it really took close to no effort, because it's all already in the events. There's no triggers, no polling, no guesswork involved. And that's the strongest advantage of event sourcing. You can always add a new asynchronous process You can always consume any change in the system, and since all state changes are expressed as events, there is no patchwork involved ever. You can integrate with anything that happens and react to anything. No plugins, and that's a very crucial advantage of the system. So, to recap, we have achieved a clean location of our domain logic because we have encapsulated it in entities that are clearly defined, are independent, do not use lazy loading, so they have predictable performance characteristics. That's actually domain-driven design, but a framework that I'm going to link to in the next slide actually incorporates that too. So you get both entities and event sourcing itself. Now, this logic is only exposed in methods, not event handlers, not util/lib.js, you know, the last pesky file that always contains all the bugs. So we have got the place to put our logic in, and it's always obvious. You open the entity that's responsible for the part of the domain logic, and it's always in there. Now you can also trace what's been happening in your application. So for instance, assume there's a logic bug that's happened some time ago, but you've only noticed it now, and you want to simulate and replicate the exact same state of the entire application at the time that the bug happened. I have done it in the past. I have actually employed binary searches on application state, so on the large event stream, to isolate a single point where the things go borked. And it has worked, because I can just replicate the application state at any given point in time. And that's a tremendous advantage. You can always query for more statistics. You can build new reports and OLAP tasks from the data you already have from day zero. And also, it's a debugging aid. Last but not least, such systems scale extremely well. As we've already seen, adding a new instance of database is only a matter of adding a new consumer for event stream, and it's as simple as launching a new process. You do not have to rely on any inter-database connections, so your database doesn't even need to implement any kind of clustering for it to work. You just deploy multiple instances, and they are built asynchronously. They are not guaranteed to contain the same data at all times, so they exhibit what's called eventual consistency. But you've got scaling basically for free. The same goes for asynchronous business processes. If you're using an enterprise message bus such as AMQP, you can, and your business process controller is suffering from some performance issues, you can just add a new one because it's all message based. So you can basically add a new worker, and it scales itself. So now I've outlined why I have invested so much in this event sourcing, and I think it's a great thing for you to explore it. Now, the code samples that I have shown you have been based on an event sourcing framework that I actually wrote when no other event sourcing frameworks in JavaScript have existed. It was I don't know, 3 or 4 years ago, I guess, that I started this project. So the first link leads to the framework. It's not very well documented because it's a one-man project, but it still powers some systems in production today. So I advise that you check it out and also compare it to other event sourcing implementations. There's at least one other project that I know of. It's called Node.js, and it's written in TypeScript. Well, ESDF is written in pure JavaScript. Actually, it's ECMAScript 5, so you do not need any fancy versions of Node even to run it. So just check it out. And also, the sample code has been shamelessly pulled from an example application that's actually runnable. So you only need a Redis instance and a Node installation to try it out for yourself. You can see what makes it tick. The code is rather well commented, so you can just check it out and see what it feels like to run a real event sourced application. You can just go into Redis and see that your events are there. You can trace the history from point 1. So I expect that not every one of you will be completely convinced. Oh, sorry about that. Especially given that not all of us are backend developers. But it's still a great technology to explore. So I will be really glad if I ever see any code that uses event sourcing. because it's really inspired me, and I hope it inspires you too. And that's all from me. Now is the time for questions.
Ilarion.
When your app crashes or at the initial bootstrap, do you get the entire history of events or a snapshot from some storage?
You mean how you load aggregates?
Yes.
How you load entities? Okay.
Well, your app was running for some time. It generated events and it has put it into storage.
Okay. Yeah.
And then you restarted.
Okay. Let's actually. You restart the application, right? So your events are still in your database. Redis can be configured because I'm using it for a persistent mode, so your events do not magically vanish. And when you restart the application, it actually is stateless. So it's the same as if you never started it, but your events are still there. So let me go back to this slide where I'm loading the entity. So this actually, what it does under the hood is take the event stream and replay it one by one by calling the appropriate event handlers. So it just creates a new instance. Actually, it calls new auction here because we have passed the constructor directly to the function. So it calls new auction and then keeps calling event handlers one by one until the very last event in the database. So if there's a million events, it's going to take a while. But you can use some snapshotting techniques. And just keeping in mind that a snapshot is not the source of truth. It's only auxiliary, and you could remove it at any point, and the only thing you would lose is performance. Okay, so we actually do use snapshotting in production, where we, for instance, every 100 events, subsequent events, make a snapshot and save it to Redis on an outside database. And then we can rehydrate from the snapshot plus any events that have happened since. But it is not necessary for event sourcing to work. Does that answer your question fully?
Yes, thank you.
You mentioned domain-driven design and that you've created a huge application using event sourcing. And my question is, you probably have a lot of bounded contexts in your application in the entire domain. Do you use event sourcing for all of them?
Yes, I use event sourcing for all of them, besides one bounded context, which is notifications. Notifications are basically events, not events, but messages sent to users, which just tell them that something's happened, and they are purely instrumental, and they can be regenerated from events. So they're basically like a reporting store. They are throwaway, and if they get lost, then nothing's really lost. So I don't really use event sourcing there, but yes, the code base does use event sourcing for user management, permission management, and maybe 5 or 7 different aspects of an ERP software, because that's actually what I make at my company. So, yeah.
Okay, thanks.
Another question? Oh.
Is it possible to replay the events with the original intervals between them?
With additional intervals?
With the original intervals.
Oh, you mean the time? You mean preserving timestamps?
Yes.
Well, if you do save timestamps with the events, then it surely should be possible. The first slide that actually had any content in it showed you the arrow of time. And there's obviously some gaps between the events. You can save the timestamps, and although my framework does not do it for brevity, you could save the timestamps and just replay it in the same interval. Now, this is a representation of a single entity, but you also have another tape-like structure, and that's the original event stream of all entities. So there's just pointers from the global stream, from the global ordering of all events in the system, to particular entities. So yes, you could replay the whole world and also keep intervals between the particular events.
Other questions? All right, so one question from me. How big is the database?
How big is the database? I'm not I'm not talking in terms of storage space because that's a pretty pointless metric. I mean, it's all JSON, so 90% of the storage is the property names probably. But the database is over 3 million events now and growing. It's running as we speak. So, okay, that's not a lot perhaps. Sorry, 3 million commits. And a commit is a group of events that's committed atomically. We have commits that span 50 events or so. So, yeah, multiply that in your head and you get the idea. And it's all stored in Redis, not a glitch so far.
All right, thanks a lot.
Thanks.
Well, so big applause.